this example, we will use MeVisLab, or Medical Visualization Laboratory, to create from scratch a 3D visualization of the PET surface and volume of interest. In MeVisLab, and use the module Quick Search to find a file loader. We will use the ITK image file reader. Give this module a descriptive name like T1. Double-click on the module and browse for your skull script T1 MRI. Close the Properties box with the red X, not the Close button, which unloads your image. We need a 3D viewing module like View 3D. Click View 3D to open the viewer. The triangles of both modules. The left mouse button to drag and rotate the image. Shift or cursor key to move the image around. The Shift and the cursor key to zoom the image. The sliders in the Clipping tab to clip into the image. Notice how the image is rescaling as you do this. The right mouse button to change the windowing and thresholding. You can prevent the rescaling by unchecking Auto View All. You may hide the orientation preview and annotations or background. Add another file reader for the PET scan, or just copy and paste the first file reader, then rename it PET. Click and browse for your PET file. You could connect this PET scan to the 3D viewer if you like, but we have other plans for it. Load a new module called isosurface to depict a surface rendering of the PET scan. The PET file reader to the isosurface module with the triangles, and then the half circles of the isosurface module and 3D module, and disconnect the triangles. We'll click on the isosurface module and change the ISO value to something smaller. Be sure to click Auto Update and Auto Apply. We need the SOWEM renderer to modify the color. Squares of isosurface and SOWEM renderer. This half circle to connect to View 3D. Now change the color of the isosurface. Let's choose blue for a hypometabolic feature like this. If the ISO value is enough, you'll see holes appear in the PET scan, representing the more hypometabolic regions of the study. The goal is to find an ISO value that shows the fewest holes. These are the most hypometabolic regions on the lateral surface. Fortunately, this method will not show the interior surfaces very well. And of course, missing regions are difficult to see because they're not there in the image. We need an alternative way of visualizing the hypometabolic cortex on the MRI. may superimpose at the co-registered T1 and clip it, but you can't clip the isosurface. Copy and paste these three new modules to use with another image. Here we will rename the PET file reader as PET VOI. Click and load your PET VOI image. This as well to the 3D viewer. Change the color to red since this VOI is inverted in intensity and is also segmented to show only the cortical portions of the PET. Notice this region appear in the whole of the PET isosurface. The ISO value to show more or less of this hypometabolic cortex. You'll often find tiny rims of dura at the extreme surface. Change the resolution to see more detail, but it takes longer time to render this. Connect the T1 to viewed 3D. Disconnect the PET isosurface, the most hypometabolic cortex of the MRI. If MeVisLab sees the regions on the wrong side of the brain, you can make a quick viewing adjustment. Load 3 copies of ITK Flip Image Filter. Insert them between the file reader and the viewer. In case we want to change Y from 0 to 180, flipping front and back and left and right at the same time. Of course, you want the same arrangement for all of the images. In various planes illustrates that this most hypometabolic region is in the left superior temporal gyrus. Be sure to save your new network. This can be used as a template when you start a new patient's study.